Okay, so this is the Excel portion of that PortaCom project. So what I've done, I'll walk you through the spreadsheet. So the first thing is in column B, in column A I just wrote the trials, and what I did is I associated a random number with each trial. And this random number is any number between 0 and 1. I use the rand function. You can see that here in the formula bar. I just made a total random list of numbers between 0 and 1. You can scroll through here if you want to look at all of them, but I did 100 trials. So we're doing 100 trials. Each trial is associated with a random number. Then I used that same formula to figure out the labor cost. So what this is saying is it's saying based on the random number in column B, if that random number was less than 0.1, then my labor cost would be 43. And you can see here in trial 11, that random number was less than 0.1. So that gave me total cost of the labor cost of 43. If it wasn't less than 0.1, then if it was less than 0.3, give me a 44. That doesn't happen for a while. Trial 20 is the first time that happens. And then you can just read through it. It's the exact same formula that I talked about in the video. But this gives me all of my simulations of labor cost. Then my parts cost, remember that was uniformly distributed 0 to 100, like the same probability for anything 0 to 100. So the formula I used was 80, and then plus the random number from B times the difference between the two. And this is going to give me numbers that are between 80 and 100. Every number has likely probability. Then for demand, so demand, that was, remember, so for demand, remember this was mean 15,000 and standard deviation 4,500. So what I'm doing here in column E is I was taking my random number from column E and then doing a norm inverse. So norm inverse says take a probability and it'll give you the numbers, whereas norm distribution, that was giving you probability. So they're kind of inverses of each other. So this gives me 100 likely demands. And then once I got that, I did that profit equation. So the profit equation was $249 times my demand minus the labor cost times the demand minus parts cost times the demand, and then minus that $1 million in advertising and admin costs. And that gives me profits. So what we've done is we figured out 100 likely scenarios for this company. I mean, all of these could happen based on the information that we've been given, and that's what's in column F. I think maybe another interesting factor is over here in column H and I. So the mean profit, and this is what they can expect. All I did was go through and average everything that was in column F. So this is the average profit they can expect is 643,811. The standard deviation was 420,681. That's kind of high. I mean, that's almost the mean, which means that there's a large spread as to what can happen with this company. For the minimum profit, I just did the min command, MIN, and then the maximum was the max command. The number of losses, you might not have seen this command before. It's the COUNTIF command. So the COUNTIF command, if you look in the formula bar, it says COUNTIF, so that means count the number of cells in column F, so F2 through F101, that are less than 0. So this is all the profits that are less than 0. And I got 7. As far as the probability of that loss, it would just be the number of losses divided by the total number of trials, which for us was 100. So there's a 7% chance that they're actually going to lose money over the next year based on these 100 simulations. Now, of course, we could do 1,000 simulations and these numbers might be better. We could do 500, however many we want. It's just really dragging the cells down. I mean, once you get this, the formula in, just use this bottom little square and drag down the formula. But we've done 100 simulations for this company. Columns I and H are what they can expect.